Today we're going to discuss Goal 13, writing an equation of a circle, given the center and the radius, and Goal 14, determining whether a point is in the interior, exterior, or on a circle. To do this, we're going to need to know the distance formula. Again, the distance formula has been given to you at the top of the note sheet. So to start, if we assume the center of a circle is at the ordered pair HK, so this would be the center at HK, and then we want to discuss any point on that circle, so any point that makes up that circle, and we'd call that point xy. I could find the distance between those 2 points using the distance formula. That would give me the radius. So if I take the distance formula and just substitute r for d, that gives me that the radius is equal to the distance between those points. X and y here represent this point on the circle. H and k represent the center of the circle. Removing the radical, I need to square both sides. That gets rid of the radical because they're inverse operations, leaving me with x minus h squared plus y minus k squared equals r squared. That is the equation that represents a circle, assuming hk is the center of the circle and r is the radius of that circle. That's the equation we're going to use for the rest of the lesson today. Given the circle to the left, what is the radius? We can find the radius by counting out from the center 1, 2, 3, 4 units, so the radius equals 4. Second thing I want you to find is the coordinates of the center. Remember, it's x comma y. So the center point here is at 2 in your x direction, 1 in your y direction. 2, 1. Using the equation that we derived from the distance formula, I can go ahead and write the equation of the circle that's on that coordinate system there. In this case, h is 2. It's the x coordinate of the center of your circle. K is 1, the y coordinate of the center of your circle. So my equation, in this equation, x and y will always stay the same. You're going to be substituting in for h, k, and r. So I would write my equation as x minus, instead of h, 2 squared plus y minus, and instead of k, 1 squared equals, it equals r squared, so I'm going to have to square r. R squared in this case is 4 squared, or 16. So the equation of the circle to the left here is x minus 2 squared plus y minus 1 squared equals 16. One other thing to note here is that it's always going to be the opposite of your x coordinate in the parentheses with x, the opposite of your y coordinate in the parentheses with y. And that's because your equation calls for x minus h and y minus k. For the next two examples, we're going to use the same equation. We just don't have the picture to draw from. But they did give us information, a radius and a center. So if the radius is 8, that means that the radius squared is 8 squared, or 64. The center is at 2, -1, so h is 2, and k is -1. I can set my equation up. It's always going to have x and that's squared. It's always going to be addition. Y is squared and equals. I have these 3 blanks that I need to fill in. H, k, and r squared. They gave me that information. I can fill it in. R squared is 64. That's what'll go in at the end. h is 2. I put the opposite of that in the parentheses. K is negative 1. So with y, I don't subtract 1. I will add 1. Again, it's the opposite. So the equation of the circle centered at 2, negative 1 with a radius of 8 is x minus 2 squared plus y plus 1 squared equals 64. Couple small tricks to number 2 here. First is with your radius. They give you a radius that's the square root of 3. Our equation for the circle needs to be the radius squared. So if I square the square root of 3, remember, just like up at the top when we were squaring both sides of the quadratic or of the distance formula, it eliminated my square root. So squaring both sides here, r squared equals 3. Squaring this square root of 3 cancels. The other trick here is the center. The center is at the origin. You have to know the coordinates of the origin. The origin is at, that's right, 0, 0. So, a couple ways we could write this. There is nothing wrong with writing this equation as x minus 0 squared plus y minus 0 squared equals the square root of 3 squared, or r squared, which is 3. There is nothing wrong with writing this equation this way. However, you will often see it written in a slightly different way. X minus 0 is just x, so we don't need the minus 0. So we can write this as just x squared plus y squared equals 3. Either way, I will accept, but you need to be able to recognize that when there is no adding or subtracting to your x term or to your y term, or to both, that coordinate is a 0. All right, the next thing that we're going to be asked to do is to look at equations, pick out the information that we've been looking at, and then graph the circle. I'm not expecting perfection on this. Circles aren't the easiest things to graph. I just want to get a general sense and a general idea that you understand what's happening. So we have to identify the center of the circle. Remember, the center is going to be the opposite of your terms that you're adding and subtracting to x. Since it's x minus 2, your x coordinate will be a positive 2. And since it's y plus 1, and this should be a squared symbol up here, you have your y coordinate of negative 1. The second thing to keep in mind as we're working backwards, what the equation equals is r squared. So r squared equals 64. To find the radius, we have to take the square root of that, which is 8. So my radius is 8. Couple things I expect to see when we're graphing. I expect to see the coordinates of the center exactly right. So at 2, negative 1, you plot the center of your circle. I want to see that dot representing the center of your circle. The next thing is, I only need 4 other points. I need to find the radius. You go to the center of your circle and count up 8 units, down 8 units, right 8 units, and left 8 units. Put those 4 points in. That represents your radius. 1, 2, 3, 4, 5, 6, 7, 8 points up, 8 points down, 1, 2, 3, 4, 5, 6, 7, 8 points to the right, 1, 2, 3, 4, 5, 6, 7, and 8 points to the left. Now, obviously it's a circle. It's not going to be the easiest thing in the world to graph. I'm not going to make you put any other points in here because it's just not necessarily going to be worth it for our purposes. You won't need to know them for the test or for the quiz. So graph your circle as close to a circle as you can. I'm not looking for perfection. Mine certainly won't be. As long as I can tell it's not a diamond and that it is relatively close to a circle, everything will be fine. Quickly going through number 2, the center of my circle. Remember, if there's nothing we are adding or subtracting to your x term or to your y term, then your coordinate for that term is 0. We are subtracting 6, so the coordinate for the y value of your center will be a positive 6. Your radius is going to be the square root of what we're equal to, so our radius is 4. I'll graph the center at 0, 6. Put my 4 points in, 4 units away from the center. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Go ahead and graph as close to a circle as we can. And we're done. The last thing that we need to discuss is goal 14, and that's whether a point lies inside a circle, outside a circle, or on the circle. Now, there's a couple of ways that we could do this. The way that I'm going to show you, I think, is the one that will take the least amount of time and hopefully can make a little bit of sense as well. And first, I'll start with the summary in the box at the bottom. If x minus h squared plus y minus k squared equals r squared, so if we get an equation that winds up being exactly true, when we substitute in our values of x and y, the center of our circle, or the x or y that is new, then if it's equal, that point is on the circle. If we substitute in and we find that the value we get is less than the radius squared, if it's less than, it is inside the circle. So we want to think about that as the distance from the center to our point is less than the radius, which is the center to the outside of the circle. If it's less than the radius, then it has to be inside the circle. And then conversely, if it is greater than r squared, it is outside the circle. So, quick example, 5, negative 3. If I'm doing 5, negative 3, I'm going to substitute into the equation I was given, 5 minus 1 squared plus y minus 2 squared, and I'm checking to see if it equals 36. And I already made one small mistake. It's not y. They told me what y was. It's negative 3, so I do have to substitute negative 3 in there. 5 minus 1 is 4 squared plus negative 3 minus 2, negative 5 squared. That's 16 plus 25. That gives me 41. 41 is bigger than 36. Because it's greater than, that falls in this last category. This point, 5, negative 3, must lie outside the circle. I want you to try the same thing with the last two problems, please. And through the magic of screencasting, the answers have appeared. We see that in both cases, the value is less than our radius squared. That means in both cases, the point is inside our circle. Our quiz on this material will be next week on Tuesday. You can now work on goals 13 and 14 in your goal packet. The quiz will cover goals 12, 13, and 14.